Imagine a star so massive it makes our sun look like a grain of sand. Now imagine that star has a black hole eating it alive from the inside, right now while it's still shining. That's not science fiction. Astronomers call it a quasi-star, and it might be one of the strangest objects ever theorized to exist in our universe. Let's go back, way back, to the first few 100 million years after the Big Bang. Back then, the universe had none of the galaxies we recognize today. Nos alarms, no familiar constellations. Just vast clouds of hydrogen and helium, drifting through total darkness, slowly collapsing under their own gravity. When those clouds finally did collapse, they didn't form gentle stars like our sun. They formed monsters. Astronomers call them population 3 stars, the very first generation of stars, built from nothing but raw, unprocessed primordial gas, with none of the heavier elements that later stars would contain. These stars could grow to hundreds, even thousands of times the mass of our sun. And when a star gets that enormous, something strange starts happening deep in its core. The pressure, the heat, the sheer, crushing weight of all that gas pressing inward. It becomes enough to collapse the very center of the star into a black hole. While the outer layers are still burning, still shining, completely unaware of what's happening at their heart. Picture that for a second. A black hole forming inside a living, breathing star. Not destroying it. Not yet. Just sitting there, feeding. This is the birth of a quasi-star. Here's where it gets even stranger. You'd expect a black hole to instantly devour everything around it, right? Rip the star apart in one violent flash of light. That's not what happens. The outer layers of the star are so massive, so thick, that their gravity actually pushes back against the black hole's pull. It becomes a cosmic tug of war. The black hole wants to consume everything in reach. The star's outer envelope resists, holding its shape, refusing to fully collapse. The result is bizarre. A stable-looking giant star on the outside, glowing steadily across space, while a monster grows silently in the dark at its exact center. Scientists estimate a quasi-star could stretch wider than our entire solar system, wider than the orbit of Saturn. And inside that colossal shell of gas, a black hole quietly grows heavier, second by second, hidden from view. This isn't a slow trickle either. The black hole at the heart of a quasi-star could gain the mass of our entire sun in less than 1,000 years. On cosmic timescales, that's almost instant. So why does any of this matter? Why should you care about a star that may have existed over 13 billion years ago? Because quasi-stars might solve one of astronomy's biggest unanswered questions. How did supermassive black holes get so big, so fast? We've found black holes with billions of times the mass of our sun, sitting at the centers of galaxies that existed when the universe was barely 1 billion years old. Under normal black hole growth, slow accretion over billions of years, that timeline doesn't add up. It shouldn't be possible, unless something jump-started the process. Unless the very first black holes weren't born small and grew slowly. Unless they were born already massive, seated inside quasi-stars, growing at incredible speed before the outer shell ever collapsed. This idea is called the direct collapse theory, and quasi-stars are currently the leading candidate for how it could actually happen. But eventually, nothing lasts forever. Not even a star this strange. As the black hole keeps feeding, it eventually outgrows the star's ability to hold it back. The delicate balance breaks. The outer envelope, no longer able to resist gravity's pull, begins collapsing inward. In one final, catastrophic moment, the remaining star matter gets pulled into the black hole. What's left behind isn't a star anymore. It's a black hole already carrying the mass of tens of thousands of suns, already a giant, already ahead of the game, ready to keep growing into the supermassive monsters we see powering galaxies today. Quasars, some of the brightest objects in the entire universe. Here's the part that should really stop you in your tracks. We have never directly observed a quasi-star. Not once. Everything we know comes from theoretical models, physics equations describing what should happen when a star grows too big, too fast, too early in cosmic history. But that might be about to change. The James Webb Space Telescope is peering further back in time than any telescope before it, catching light from galaxies that existed when the universe was still in its infancy. And some of what it's finding doesn't fit our existing models. Objects that appear too massive, too soon, earlier and heavier than current theory can easily explain. Could quasi-stars be hiding in that data? Could astronomers already be looking at one right now without even realizing it? Nobody knows for certain yet, but the search is actively on. Think about what that means. Somewhere in the deepest images ever captured of the universe, the light from a quasi-star might already be sitting in our data, waiting to be recognized for what it truly is. A star being consumed from the inside out. A black hole hiding in plain sight. The seed of every supermassive monster that powers galaxies today. So next time you look up at the night sky, remember this. Some of the earliest stars in the universe may not have been stars at all. They were something else entirely. A battle between gravity and consumption, playing out on a scale we can barely comprehend. If this blew your mind, follow for more mind-bending space facts you won't find anywhere else. And drop a comment. Do you think we've already photographed a quasi-star without realizing it?